Good to see you guys all here. Just as a way of sort of me understand where you guys are at, how many of you are running Visual Studio Preview? Mike. Good, good. Okay, how many of you are running or compiling in C# 10? Few people. How about C# 8? Okay, 9. Okay, so I'm going to figure out how to guess. How about 11? Writing in C# 11, .NET 7, C# 11, .NET 7. Okay. So other than that, how many of you are not using .NET? Okay, good, the Python folks. Okay. Okay, so that's good. So we're going to go ahead and look at C# 11, but some of the stuff that we show you, you might not be familiar with if you're not yet using a more recent version of C#, and we'll try and sort of talk that through. It's interesting to see the features that have come out in C# 11. There's nothing radical, so it's not going to sort of change your world. You're going to start programming differently in all cases, but there's some really cool cases where you almost certainly will start using the feature every time. Start out, let's go ahead and look at strings. You would think that in a world of strings, we've kind of got this figured out. There's no real improvements we need to do anymore. But it turns out if you ever want to go ahead and type a JSON string in C#, it is a pain in the patootie. As I've demonstrated by the code up here, this is a string, it's got a string literal here, and we've gone ahead and embedded some code in there. And it's a fairly painful thing to go ahead and write sort of JSON in C#. And so what Microsoft has done is sort of started to make this easier. And so we've got a unit test here. The unit test is going ahead and running. And we're going to go ahead and change actual to start using what is called a raw string literal. A raw string literal. So a new feature coming in C# 11. And to start that out, Meg, why don't you go ahead and change the quotes there to triple quotes. We're going to use triple quotes on each side of the string. And so we'll go ahead and do that. It's not compiling yet because we've also changed some other things. But before, if you wanted to do a string literal, you put an @ sign in front of the string, and then it counted all the white space. So the white space that appears here, this counts as part of the string. But the other part of that is you had to go ahead and outdent your code back here, so it totally messed up your tabs. And for all of us, this is what was basically sort of made C# not such a great language, because we got indenting that doesn't quite work. That sort of lost status for us when we had to do that. You guys think I'm kidding, but I'm totally serious. I guess a big deal. So one of the great features about a raw string literal is we no longer need to worry about that. So we can actually go ahead. Why don't we just change it, not for the purpose of the test. Can we just get this compiling, Meg? Can we change it so it just compiles? And one of the things we're going to do there is let's go ahead and delete the second curly brace. There.
Please?
Well, I guess that's not going to work. That's not going to
work. We can get rid of all these.
Oh, get the double quotes. Yeah, there we go. Thank you.
Here, yeah. There's just
so we just want to get it compiling. Get rid of our double quotes. Again, that was a pain, right? We had to go write our string literal before. We had to put double quotes every single time we want to do quotes. And we no longer have to do that. So just right there, we're doing better. Okay? So 3 quotes on each side, and already we can go ahead and not have to do double quotes in order to escape, in order to do a single quote in our actual string.
Do you want to talk about the $?
I do, but before I do that, I want to talk about the indentation, because that was the most important part of this feature.
Okay.
Yeah. So the other thing that's really interesting is we can go ahead and indent this. So let's go ahead and tab that in to exactly where we want it to be, and it just works. So now the obvious question is, well, exactly where does the white space matter and where does the white space not matter? And it turns out that these 3 quotes are the beginning of the string. So everything that appears before this quote on this side, that's going to be ignored. But wherever this quote appears, that's going to pay attention. So these 5 spaces here will appear in your output. But if you indent those 3 strings, then those 5 spaces that were here, or now what is 8 spaces, those will not appear. So you can now indent your code and have the string just correspond to that exactly the way. I know it seems like it's just really simple, but this is a big deal. It's a big deal. So the other thing to note is if you go ahead and have those 3 quotes indented further than anything else in your text, it's going to give you an error. It's like, hey, what are you talking about? I don't deal with the stuff back there. We're not using that stuff. So you're really using those 3 quotes, ending 3 quotes. That's your delimiter of sort of where is the end of that. great. So let's go ahead and look at something else. So the other thing to note, you want to put that outdented on that line 24 there. The other thing to note here is we do actually want to do some string substitution. And so we'd actually like to go ahead and inject the name in there. And the problem is when you write your JSON string is it turns out JSON happens to like curly braces as well. And so now we've got a dilemma. Okay, are the curly braces related to the fact that I want to do string interpolation, or the curly braces to the fact that I just want row strings? And the number of dollar signs you have symbolizes how many you need of the curly brace to do string interpolation. So if we go and specify two dollar signs at the beginning, that basically says every single time you have one curly brace, it's going to count as a curly brace. Imagine that. It's going to count as a curly brace. But if you have $2 signs, then you can go ahead and do string interpolation by putting two curly braces to indicate, hey, I want the data that's embedded inside name, the value that's within name, I want it to go ahead and appear and get embedded inside the string. One last thing. It turns out that quotes are very significant inside JSON strings. It turns out they happen a lot. And so when we started out, one of the big problems we had is we had all these double quotes to go ahead and escape to get a single quote. Does that make sense? Double quotes? No, double quotes, I think is how you'd say it. And so now what happens is you can actually go ahead and use an additional quote for the identification of your raw string literal. So we can go ahead and put a quote there, and at the end is quotes as well. And then that would basically say, okay, if you want a regular quote to appear out, you can do that, but you have got to have a double quote to go do it. So you can change the significance of quotes by putting how many quotes you actually want to appear at the beginning. Yeah, so go ahead and put 4 quotes there, Meg.
Yep. There's 4.
Oh, you have 4 both. And if you go ahead and put a quote there, that says, okay, now you actually want a quote to appear in the text. So the number of times you put the 4 quotes, it basically says how many times you want the quote to appear.
We can run a test.
Just to call this out, so you guys are, why don't you get the test? Is the test running at this point?
Yeah, I'll run it. It's thinking.
So if we put a double quote here, like we had a double quote there, it's actually going to have double quotes appear.
So now we're failing.
What's that?
So now we're failing because the double quotes are appearing since we've only got 1 quote here. So this is.
We've got 1 quote carrying the string. We've got 2 quotes here. So we've got 2 quotes coming out here.
Yeah. Because if you only had 3, then you would be having. So.
Questions? Again, pretty minor feature, but I bet from now on you will all use raw string literals rather than string literals as they appeared before. There is a graveyard for backslashes, so if you guys could go check it, it's graveyard.com. If you guys look it up, you can put them there. Okay, great. Let's keep going.
Do you want to talk about DTF?
Oh yes. Oh, that's a good point. There's another really important feature that you guys have all been very anxious about. Thank you for reminding me on that one. Haven't you guys all wanted to put UTF string literals in your code? This is really important. You've got to get UTF-8. Raise your hand, UTF-8. That's been a big deal for you. Absolutely, yeah. So it turns out we can now go ahead and do raw string literals with UTF-8. And to do that, we're going to go ahead and suffix the string that we have right there for const. We're going to go and suffix that with a UT8. And that goes ahead and converts it into a UTF-8 literal. Unfortunately, the data type is no longer a string. So to figure out what the data type is, we're going to go ahead and delete the const string, and we're going to put var. Don't ever do this at home. We're going to go ahead and put var, and then we're going to do a dot period and hit enter, and it's going to expand that out to be what the data actually is, because you would never leave a var in your code unless you're writing JavaScript, and that's why you program in C# is you don't want to do var. So now we can actually do UTF-8. This is obviously mostly if you got to hard code in doing interop, where the encoding of the string is really important. So it's not common if you're doing an interop or you're doing some web programming, we have to have UTF-8 string. It's a way of doing UTF-8 literal right within your code. Details. Meg points out that this doesn't compile. Right now, it's not compiling because it is a UTF-8, so we'd have to go do a toString to go ahead and do a conversion on that. To actually go ahead and appear it's not a toString.
Constant.
Oh, the reason it doesn't compile is because this is no longer constant. Thank you.
Yeah.
We're now doing name. When we've had it before, we declared it as a constant. And a UTF-8 string literal is not actually a constant. It's a read-only span byte. And so we had to go ahead and convert it to a, we had to change the string that we're declaring expected to no longer be constant. Thank you. Any other questions? Okay, good. Pattern matching. How many of you using pattern matching in C#? Started in C#7. Roughly, kind of. Kind of, few people, few pattern matching. So I would love to spend a long time talking about pattern matching because there's tons of features in pattern matching, but we're going to focus on the ones that are exclusive to C#11, which is the ability to go ahead and match from lists. So we what we call list pattern matching. So to start, let's go ahead and do assert dot true, and let's specify the exact same text that appears in the array above. And let's go say items, and we're going to go ahead and do a pattern matching. You killed my father, and get the exact same data out. And in this case, what we're saying is, hey, you can pattern match on data and make sure it actually matches exactly what you want it to be. So I can say, hey, this is true. These are actually go ahead and equivalent. This will go ahead and match your pattern. We can also go ahead and put ellipses in here. So we could, for example, go ahead and do an assert true, items is, and then we can do curly brace. Now we can do dot dot, and then do comma, and do father, and we can go say, hey, that'll match. For any number of things before that, we can go ahead and match that string. What's interesting to point out here is the dot dot doesn't count. It's not saying, oh, well, it must be one item. It's saying it could be any number of items as long as the list ends in father in this case. Let's go do the same thing. We put it in the middle. So let's go ahead and do, hey, we're going to put you, we're going to dot dot, we'll go ahead and match. In this case, we're saying, hey, you can go ahead and match any number of items in the middle so that goes and work out. Any questions? How are we doing?
Does that only work on arrays?
It works on anything that supports an iList interface. So anything you can index into. Yes, thank you. The question was, does this only work on arrays? And the answer is no, it'll work on anything that is a list. It can be indexed into. That's a great question. Thank you for pointing that out. So anything you can go ahead and do index of operator on, then that'll go ahead and work. So something that supports the list, the iList interface. Again, the ellipses there, which there's only two of, so I'm not sure it's an ellipse. Does ellipse have to be three? I'm not sure. Okay, well, when you go ahead and do that, it specifies it doesn't matter how many items you're going to do. You can, of course, remove everything from the list. So we can say, I don't care what the items are, but it must be a collection of items. So we can go ahead and just eliminate them entirely to go say, hey, this must be a collection of items that we're going to go. It will work even for, great question. So the question was, will this work for a would it require it to be non-zero? And the answer is no. It just has to be indexable into the list. That's not counting the items at all. It just implements an item. Good. Let's go ahead and do the same thing. Let's make it empty. So let's go ahead and have no ellipse in there. Right, picking on your question here. So if you want to make sure there are no items in the collection, then you would go ahead and do that. So thank you for that question. That was perfect timing. It was just where we needed it. Did I make another question?
Yeah, I was going to ask. This works just Boolean.
It does. The question was, does it return as just a Boolean? The answer is yes, it returns a Boolean. But let's remember the context. I'm using the is operator for pattern matching. The equivalent code will work if you were doing a switch expression or a switch statement. So just to be, most of the time we're doing this, we're trying to match lots of different things. Then we would go ahead and put this inside a switch statement. So the exact same expressions I'm using to the right of the is operator, you can use within a switch expression or a switch statement. Doesn't have to be either one. That'll go ahead and work. Which is a typical scenario we'd see this work.
I think we will get to an interesting case in just a little bit where you can actually assign check variables.
Yeah. Before we get there, though, there's a little bit of an interesting example. If you go ahead and do, let's just do you killed.
See, duplicate one of these.
Good plan.
I don't like to type.
That's a good job. I agree with that.
And then ellipse here.
Yeah, or just without it. Basically, if we say you killed, that's not going to match, right? So if we actually have the exact text here, we actually change true there to be false. Items does not match, so 15 is going to be false, and that's not going to go ahead and match, even though we've got the first two items. And obviously, if we want to make it match, we put the ellipses afterwards, and we're fine. Okay? What is unfortunate is you can't go ahead and specify, I want to match on anything where killed and my appears in the middle. So we can't go ahead and specify, hey, you killed my, and then put ellipses afterwards. That syntax is not going to be valid. You can only have the ellipses appear once. So the slice operator is only going to appear once in the string. That's not going to compile. If you wanted to do something like that, you would have to go ahead and use the index operator. So here we can go ahead and do items, and then specify items and change items, actually on items, to go ahead and change on items.
Oh, sorry.
Array operator there. Yeah, so here we can say, hey, from 1 to #1. So again, this came out, I think this is a C#6 feature. You can say, hey, from the first operator to 1 less than the last operator, then we can go ahead and match on those items. But that still isn't quite the same because I'm looking for an exact match. So it's not the same, I got ... and specific text in the middle, because I'm actually knowing, I have to know preemptively at compile time, I need to know, it doesn't have to be. I have to know that this is the first item and I'm skipping one item, exactly one item, not n items. Questions about the list pattern matching? There are a couple more interesting scenarios here that are worth talking about. Since a string is an array, we can now do an array within an array. And so you can actually get more complex in your pattern matching. So in this example, we can sort of say, hey, let's do a pattern matching for a list, and then let's do another array operator in there, and let's go ahead and specify y, and then comma, and then ... So now we're specifying, hey, u and any number of characters after the u for the first element in the array. And then we can just go ahead and we can do more of them. We can go ahead and put a comma, ... and then we can do, father as well. And so we can operate on any items that may come in there. Make sense? So now we're saying it has to be a list, and within the list, there has to be another array, and within that array, the first item within the array begins with y, then any other elements in the array are relevant, and then for the rest of the items in the first array, we're going to go ahead and pick out that. And just like we can get support in earlier versions of pattern matching, we can still go ahead and do string declaration at the same time. So we could, in this case, go and say, hey, if the items are matched, let's go ahead and pull out data. So in this case, let's go ahead and do an if items is, and let's specify there just sort of u ... And then instead of specifying father, we could actually just declare a variable. So we'll go ahead and say string and specify last word in the sentence. And now we're actually doing declaration. So it's going to go do pattern matching. It's saying, hey, the last item in this array, that's going to be set to the value last word. Now we can go ahead and do assert. So not only are we pattern matching against what the data is in there, we now can pull data out and say, okay, now that we know what this is, we can work with that value inside that list. Again, the fact that you can do declaration is not a C#11 feature. That's been true since C#, I think 7 actually. But it is a big asset to be able to get the variables as you do the pattern match. If you were doing something like a switch expression, we'll often see things like switch expressions require literals. So we could do something like a when. For those of you who are used to pattern matching, you can now do when on a switch case. So then you can say when, and you can do a much more complex expression like, hey, this has to be less than 42, or this dot length has to be something like that, and you can go extrapolate that out in the when expression. So the advantage of the declaration is the ability to do that.
Also,
Josh.
like an exception handling, right? So
Yeah, so the when expression also works in exception handling. That's true. When expressions work in the question was, can I do the when expression and exception handling? The answer is yes. You can do exception handling with when expressions, and you can use them with switch statements and switch expressions. You can use when as well in all of those cases. The difference is that in exception handling, you can't do pattern matching at the same time. Exception handling only does it based on the type that you're catching, and then you can do a when expression to say, well, if the ID of the exception or the text of the exception, you can put additional context into it. That's correct. Question? Ah, there's a good question. The question is, could you use a regex? And the answer is no, this is as good as regex. So no, you cannot use a regex inside your pattern matching. You would have to go ahead and use regular expressions to do pattern matching. But you could, just to be clear, you could do a when expression with regular expressions. So I could go ahead and, for example, I could pull out fat father as last word, and then do a regular expression match inside my when clause of my expression. That's a great question, by the way. This is basically a very, very dumbed down version of irregular expressions. The advantage being is so dumb that you don't actually have to have two problems because now you get a regular expression problem. We say that whenever you have to solve a problem with regular expressions, you now have two problems. Any other questions? Great. Okay, let's move on. Attribute enhancements. How many of you guys are writing your own attributes? Very few. How many of you are using attributes? I hope most of you, if you're doing unit testing, it's hard to do unit testing with the .NET Framework libraries, any of them, NUnit, XUnit, MSTest. So hopefully you're using attributes for that. So there's a couple enhancements to point out that's coming in C# 11. The first one you'll notice is I can now go ahead in line 14. I've now got method name as a name of. Before, you couldn't put parameters in the method you were decorating. You couldn't put the parameter names inside the name of operator, so you couldn't pull those out. And we can now go ahead and do that. This actually occurred. There's actually specific cases inside C# 8 where we needed to get access to the parameter name, and we had to type it in a string, and that's no longer necessary to do that. So it's a good enhancement, and there's specific cases where you would have had to literally type the name of the parameter again inside a string, and you no longer have to do that. So not a huge deal, but it is in the cases where you want to go ahead and access that data within inside the parameters. More interesting cases, you'll notice in line 21, we've gone ahead and used type of string. We basically want to go ahead and access the type. And if you look at the syntax for this, the question that it's begging is, why can't I use a type parameter instead of having to specify type of as a parameter into the attribute? So in line 21 there, we do inline, and then it takes a parameter in the constructor of the attribute. It takes a parameter that's a type of for string. And what would be better is we didn't take any parameters. Instead, the attribute took a type parameter for generics. And that wasn't possible. But starting in C# 11, we can now go ahead and specify string as a type parameter into the attribute rather than passing in the type of data. And so this gets significantly more complex in terms of what you can do because you've got generics inside attributes. There was no generic support in attributes prior to C# 11. And as an example of this, you'll notice in this case, we're basically saying, hey, scroll down a bit. Expect exception. Okay, we're not. So in this case, sorry, I skipped that. Okay, so in this case, we could go ahead and declare the inline data there in terms of line 36. We could change that. We could go actually modify that and actually take a type parameter for inline attribute inside the line of data. So do inline data type of.
Here.
Yeah, delete type of. Delete.
Oh, yeah.
Delete that. Delete the parentheses and make that an angle bracket. Yeah, delete both parentheses, make it an angle bracket. Delete the parentheses. Yeah, perfect. There we go. So instead of going ahead and passing type of, we can go ahead and pass the type parameter inside. An interesting thing to note is on line 41, we're going ahead and getting the name of the attribute just by calling .name, type name. However, we've very subtly changed the assert expression to be a not equal expression. So instead of being equal, you guys probably didn't notice. You probably thought it said equal. But it turns out it's actually a catch. It says not equal. Because the data coming out, what you would expect to be inline attribute, ~1, that's how generics resolve into names. That doesn't actually work. It actually puts a longer than a GUID, unique name on the end there. So you don't want to use the name that's coming through of that generic type that's coming through. So you should, and it makes sense, we shouldn't be matching on strings. We should be matching on types anyway. So as long as you go ahead and do type matching, it should be fine. Meg, if you go ahead, that's hard. I was going to say open up the test, but that's hard. Can you click on the green check mark there on that test right there? Yep, that one. Yep. And you'll notice the name there, standard output, is some really long number, even longer than a GUID. Okay. And the example that we did here, there is not actually an inline data attribute in XUnit that takes a type parameter that doesn't exist. We went ahead and defined one just to show you could actually use this in exact cases where you want to do, hey, I want to catch an exception inside this test, and the exception needs to be of this type. In the past, we had to use type of, and here we're just using the type parameter instead. But that attribute doesn't actually exist in XUnit. We've gone ahead and just defined one. The definition is right there. Questions? No questions. You're doing a great job, Meg, because they got no questions. Okay.
Be nice and quiet.
Yes, exactly. Okay. Next, required. At the top, at the bottom, let's go ahead and look at person. We have got a person here, and you'll notice that the person has a nullable first name and a nullable string and a nullable date only. We want to change this to say if you have a person, then the person must have a name that should be required data, and we want to go specify that last name must be required too. So we're ignoring the case of Madonna. We're going to actually have a valid name that could be. So to go ahead and do this, we're going to go ahead and use the new contextual keyword of required. We're going to place required right before it. We're going to delete it for no longer being nullable, and now we specify, hey, this must be required. And when we do that, you'll notice back up, let's keep going up further. Here, inside that new, what's the new expression take? It says, do you have zoom it? Can you make it bigger? No.
I do not have zoom.
Okay, so I'm just going to, well, it's not going to change the size of the text, so we got a problem. Okay, so here on new, if you hover over new, I'll just read it to you. It says, hey, required member name first name, just hover again. Required member name first name must be set in the initializer. So the change that has to happen here is in the initializer, we need to go specify first name is equal to a value. So go inside line 10.5. We're going to say first name equals an eagle. And you'll notice that deals with the error that was coming up. So the only thing we had to do was go identify properties within our class as being required, and then they had to be set inside the initializer of that type. Make sense? So we could do that for those ones, and then we've got an error on line 28. What's the error on line 28?
So the error on line 28 is that you may be studying the first name here, but it doesn't quite.
Ah, yes. So still, if you hover over it, let's go ahead and read the warning. The error, actually. The warning is required member first name must be set. And suddenly our excitement about the required a contextual keyword is not nearly as exciting. We have a constructor here. The constructor requires you to specify first name. We are calling the constructor that requires you to specify first name, and we are setting the first name. And the compiler doesn't know. So unfortunately, this fantastic feature doesn't work if you have constructors in the way you think it does. So in this case, we actually have to go specify first name on line 28.5. We have to actually go inside first name. This is most unfortunate. This is most unfortunate. So from a coding guidelines, from a coding standard, I would suggest you should avoid using required properties as parameters into your constructor. Let me say it again. you should avoid using required parameters in your constructor. You can do other parameters, you can do other stuff, but don't go ahead and use required.
Do we look at the guidelines?
Yes. There's one other thing I want to point out before we do that. Thank you, but let me show one thing. There is a way to get around this. You could go ahead and put an attribute on the constructor for set required members. When you go ahead and do set required members on the attribute of the constructor, you are telling the compiler, you know best. You're basically saying, trust me, I'm a programmer. I will set everything that is necessary to set inside the constructor. And the compiler, lo and behold, will actually believe you, whether you are doing it or not. Okay? So this is great because it says, hey, I'm trusting you that you're setting first name. But you'll notice I am not setting last name. And I do have last name as required. And the need to go ahead and set last name is no longer there because in line 42, you'll notice that I can, line
30.
Yes, there. Line 30. We are not setting last name. This is most unfortunate. Okay? And it really starts to say, well, if you're really good, and when you say trust the compiler, but if somebody comes after you and adds required and forgets to change the constructor, you've pretty much eliminated the value of required. Okay? So use this with extreme caution. Let's go look at the guidelines. So first, do not use constructor parameters to initialize required properties. I showed you that. I demonstrated that. Okay? When you do, you will force people who's using your API to specify it twice. Okay? Next, do not use the set required attribute unless all required parameters are assigned inside the constructor, but you have to check yourself. That's your responsibility. Consider only having default constructors on types that are required with required members. So my suggestion to you is if you're going to use required, don't have a constructor other than the default constructor. Okay, so my suggestion, what I think you should consider when you're coding, is if you're going to use required, don't have anything other than the default constructor. And if you do that, then you're going to make sure that everything needs to be set inside the initializer, and you'll end up with an argument that is set, an object that is initialized correctly. Questions about required?
What's the warning?
It's probably a nullable one.
Yeah.
Non-nullable property last name must contain a non-nullable value. So that warning is telling you, hey, you haven't said last name because last name is not nullable.
But it is just a warning. So you can still do what you want.
Unless you turn on treat warnings as errors.
Yeah.
Which
you
I would
should
kind
have
of.
in your pipelines.
Okay. Thank you. Other questions? Yes.
So then if you remove it from the constructor there,
If I eliminate line 40, so if we eliminate line 40, what's that? If you delete it from the constructor, this is the point. Set required members basically says, do whatever you like. Just make sure you do what you really like. It's basically trusting the developer to do the right thing without any validation whatsoever. There was a really early prototype of set required members that didn't end up making the final product, but you could list all the properties that you're going to use, and that didn't make it into the release. So when you decide to use set required members, you're basically saying, I got this figured out. I can handle it. Trust me.
If you want that error to show back up on this new, you have to get rid of this. And then it will start telling you that you're not setting the required correctly. But then you have the issue with if you don't have a default constructor. Double set.
From a guidelines perspective, my suggestion is don't have a non-default constructor and don't use set required members. Yes.
Does required provide any runtime behavior?
So the question was, does required provide any runtime behavior? And the answer is no. There's no runtime behavior on required. It's only a compile check. Good question. Any other questions? Okay, a couple more things. Okay, required members on auto default on struct. Can you switch the?
Sorry, light mode hard. It's hard to operate for me. Okay.
Okay, if we scroll down, we're going to see we have here a coordinate that we've gone ahead and declared. The coordinate has a longitude and latitude and name. And the key thing we want to point out is this: when we go ahead and run the test, we are setting longitude, we are setting latitude. We're setting longitude to 1, we're setting latitude to 42. If you go ahead and do a test, where's our test?
Up here. I didn't get the right
Thank you.
test.
If we go ahead and do a test here, we notice we set it to default. We can go into assert.requal on coordinate. And let's go ahead and verify that coordinate, let's do 42, yeah, a coordinate dot latitude. Is it latitude that we did?
I think.
Yes, latitude, great. We go ahead and run our test. And it failed. Well, that's really frustrating. Okay, let's try the next one. Let's go ahead and do the same thing. Take line 10, copy it into line 18. We went ahead and used an array. The array goes ahead and initializes the struct. And we went ahead and checked what latitude it's going to be set to. And it failed. However, in line 26, let's go and do the same thing. We're going to go ahead and specify a value. We're going to call the constructor. We're going to pass in 30. And now we'll notice that it passes because we went to specify the value. Just go down to the constructor. You can show what happened. In the constructor, if you go ahead and specify a value, when we call in do the latitude, you'll notice we're using the constructor from line 38. We're just specifying the constructor. We can go ahead and do this. The key change that happened, just so you guys are all aware, is you could not specify default constructors for structs until C#11. Let me repeat. The key change here is you could not have a default constructor in structs until C#11. The key thing to be aware of is that when you do this, you cannot rely on the assignment at declaration time, but you can rely on the assignment in the constructor. So from a coding guidelines perspective, you might to go ahead and have your structs be immutable, as we always did. They should be read-only, the data that you're using. And do not use member initialization in your structs, because it will not get called. Yeah, I got it. Any questions? There is no warning or anything. That's why you write unit tests. That was the purpose of the talk, to show that you should write unit tests. I just demonstrated it right there. You can. So the question was, can you go ahead and use required keywords in struct? And the answer is yes. Required is allowed. And that will, remember what required forces you to do is specify initializer. Okay? And it's sort of, it only requires you to set an initializer. If you go ahead and set a value inside the constructor, so if you look at line 44, where we're specifying name there, that will come through. So any data you set inside the constructor will work. Okay, but not data that you set out inside the constructor. Okay, let's keep going. We got a couple more to get through, and we're almost out of time. So, just a quick one to show here. You can now go ahead and put static abstract members on interfaces. Let me say that again. You can now put a static abstract member on an interface. Well, this is weird because before we could never put anything, we could put static on interfaces, but didn't force an implementation. If you provide a static abstract member on the interface, anyone implementing your interface also has to provide a static abstract member for that interface. So why does this exist? Well, a key place this exists is you can't go ahead and force somebody to implement an add operator because an add operator was static. So one of the features that is being added in that has been added in C#11 is by putting a static abstract member onto an interface, you can force people to implement plus, minus operators and that kind of thing on their, and other operators on their types. Another example of this way this plays out is imagine if you had a type constraint on a generic where you needed to go ahead and do a factory pattern. I'm just going to talk this through here. Before, you could specify a constraint on a type parameter on a generic that said new parentheses, parentheses, and that forced them to say there must be a default constructor on the type parameter. Okay? So if, for example, you had an interface, my interface, and my interface required to instantiate the data type that you had on the generic, when you went and did that, you could say there was a default constructor, and then I could instantiate on the fly. I could just do new t parentheses, parentheses, and it would work. However, if you wanted to have any parameters in the constructor, you could not do that. Now with C#11, we can go ahead and have a factory pattern. There's a static abstract create object that takes parameters, and you could force everyone to implement below you. So the idea that you can do static abstract members and interfaces can force people to put additional static members into their class, and that's really useful, especially in the case that we have add. Last one. I got 3 minutes here. Let's go and look at. We got 1 minute.
Yeah,
Okay.
You have 2 more too. Technically, you have this one, and you have.
Yeah, I'm not gonna get to it. Do you have that screen? Can you paste that code?
Yep. Yeah. This code here.
Yeah. Lastly, you can go ahead and use regular expressions, and you'll notice there's colorization in the regular expression, even though it's just a string. That string is actually parsed by the compiler at compile time, and it's going to go ahead and convert your regular expression at compile time rather than runtime. And you'll notice if you look at this text, it's hard to read, it actually figures out what your capture groups are, everything, and actually it's parsing it at compile time. So regular expression is now going to compile time capability for you to go do. And rather than you typing that as a string, you can type it as a generated regex attribute, and then you can use that within your string. So we're moving regular expressions into have a first class a space within the data that you're trying to go ahead and write. So it's a significant improvement for those of you who are really excited about regular expressions. This actually goes ahead and compiles your regular expression at compile time rather than waiting for you to just have some magic string at runtime and go ahead and use it. That's the source code. That's where we're going to end. Questions? No questions.
Little one.
Josh.
So I saw like on the regex attribute there, that there was some text highlighting. I was just kind of curious. If I wanted to get regex text highlighting into one of my string parameters for a method, how can I do that?
Yeah, so if you go ahead and use that regular expression highlighting, you're looking at 19, correct?
Yeah.
It just works.
It just works.
So if you put this inside generated regex on C#11, it will just work. There's a set of strings that will now be parsed by the compiler that you can just put in as magic strings. I think it works for JSON. I think it works for regex. There's a few strings that basically are using string handlers at compile time to go ahead and parse the data coming in. So this one, yeah, it's even, I think it even tells you if you have an error there. I mean, it's pretty high fidelity what it's doing there, so you can check without running the code.
Oh, no, then.
Okay, any other questions? Thank you.
Thanks, give him a hand. We have just